Yeah, my name is Jean-Christophe, and I work for the company LASEA. So LASEA, we are a laser micromachining machines manufacturer. So we are located in Belgium, and we have different subsidiaries. I will show them to you later in the presentation. So my presentation today is about the 1OP. So 1OP, it means one operation. So it means how to machine one part in one operation, but I'm going to explain that to you more in details. So first, a short introduction to LASEA. So LASEA, we are a Belgian company, as I told you, a group. We have 8,500 square meters of production on six different sites. We have 3,000 machines installed all over the world. We have around 120 patents. We have machines on 5 continents, 50 years of experience. So it's quite a lot in the laser industry. We have 15 application engineers. So that's the team where they make the feasibility test for customers. So when a customer wants to buy a machine, he wants always start the project by organizing a test. So that's the team who are organizing those tests for customers. So altogether in the company, we are 200, a bit less than 200 employees, and we have an annual growth of around 30%. So just for the story, I started the company, it was a little bit less than 10 years ago, and we were 45 at that time. So it's a big growth. So just to summarize how we are organized all over the world. So I'm located in Belgium, so in Liège, so that's where we have the headquarters. And then we also have a production facility in France, in Marnay, so that's close to Besançon, and that's the company Laser Cheval. So we took over the company Laser Cheval a few years ago. Now they are a member of the LASEA group. We also have another company in Belgium, in Mons, called Optech. We have a subsidiary in Bordeaux, so called LASEA France. We have also a subsidiary in San Diego, in California, and in Switzerland for the watch industry in Biel. So that's where we are located all over the world. So we have different markets. As Antonio told you, I'm responsible for luxury, but we also have electronics and medtech. So luxury, it's mainly for LASEA, the watch industry, Swiss watch industry, but not only. We also have machines in the watch industry in Japan and in other countries in Europe. So electronics is more Asia, not only, but more Asia, and also medtech more in the US. But again, not only. Research, so it means that we also have machines in the universities and R&D centers. So let's talk about the 1OP. So as I'm responsible for the watch industry, I'm going to take an example of a part made for the watch by the watchmakers. So it's typical a part that you can find in a movement of a watch. So how they do today, the watchmaker, they start with the raw material. Can be different material like brass or stainless steel or titanium, and they want to produce this final part that you see here. So we had a lot of discussions with the watchmakers in the past years, and they explained us how they are producing this type of parts today. So I'm not going to go into details about how they are producing those parts today or before today, because it's not about laser, but it's just to show that there are many operations, like different types of machines, like milling, wire EDM, gear cutting, decoration machines. So that's only an example, but every watchmaker has a different way to produce the parts. So what I want to show here is that you have many machines and also many manual operations, like loading, unloading the parts from one machine to the other, go to the cleaning machine, and then put the parts again in the next machine. So it's quite complex. It works very well because they are doing that for more than 100 years, but it's quite complex. So our target with our laser machines, micromachining laser machines, was to make it simple, more simple for them. So I will continue with this example of the part I showed in the beginning. So with laser micromachining, you have different types of applications. So first, as you probably all know, when you machine a part with a laser, you will always have a taper. So for gear, for example, in a watch movement, of course, it's not possible to have a taper because the gear will not work. So for that, we developed a system that we call LS Precess. So it's a precision head, which will allow the laser to machine the material without taper. So in this example, you see that the part where you don't where the taper is not acceptable. So that's the drilling and also the cutting. As I mentioned before, it's very important that you don't have this taper. So how we do that? We use a laser, femtosecond laser. We place different modules that we develop ourselves in the beam path. So it's the LS shape to shape the beam, LS precess to avoid this taper, then LS polar to modify the polarization, LS view to be able to view the part through the scanning head, and then the scanning head itself. So you see here, I'm going to use the laser pointer. You see here how the laser beam look like after the laser source. Then you go into the LS shape. Then you will make it, for example, bigger, and then you go through the LS shape. So the LS shape will transform this shape, this round shape of the laser beam to like a donut. And it's because we give this movement, as you see on the right side of the slide, you can see that the laser beam is moving to compensate the taper. So the advantage is that we don't have any taper anymore, but we have like a donut instead of a single spot. So because of that, if you want to engrave, for example, you will have this donut. So it means that you will have a problem. You cannot engrave like a normal laser machine without this precision head. So you cannot engrave because of this donut. You can also not create the chamfering. You can also not make the engraving and texturing because of that. So, and the decoration, the same. So what we did, we decided to have this LS precess, but we can bypass it. So it means that, as you can see here, we don't have this donut anymore because we have a bypass. So it means that inside the precision head, we can move the laser beam to another path, and then you don't have this donut anymore. And then you have a normal machine, and that's what we call 1OP, because in one single machine you can either cut or drill without taper, but you can also make the decoration, engraving, chamfering, engraving, everything. So it means you need only one single machine to machine this complete part. And that's what we call 1OP, one operation. So as a summary, this is how the watch industry is producing the parts today. And we make it simple. We use this machine that we call LS4P machine. And then you only have the raw material at the entrance of the machine, and then you push the button, you push a start button, and then you will take the parts finished out of the machine. So it means you have only loading, unloading, one operation, only laser, only one machine, and then you can save time. You can increase your flexibility because you don't need a special tool. It's only a file, DXF file. You reduce your footprint if you compare all the machines you have on the left side comparing to one single laser machine. You reduce your overall investment because you only buy one machine and not maybe 4 or 5 machines. You reduce, of course, your energy consumption, and especially with laser because the consumption is very low, and you also reduce your consumable costs. So it's really to make it simple and flexible for the watchmaker. So to finish my presentation, I just wanted to show you some examples of real parts, just to show you the quality that we can reach. So again, we start with raw material. And then at the exit of the machine, you have this type of part. We just had a polishing, a cleaning and polishing operation after machining with laser, but it's really the part which comes out of the machine after the laser. It's really the quality that we can reach, and that's what the watchmakers need. So yeah, that's my presentation. I don't know if you have any question, and I hope it was clear and that you enjoyed.